Welcome to my YouTube channel. As you know, this channel is for ICSE class 9 and 10 physics. And here we are going to discuss about a new topic. But before going to discuss the new topic, so what you have to do to get the latest video, you have to like the video, you have to subscribe my channel, click on the bell icon and like the video if it is useful for you. So subscribe my channel to get the new updates of physics class 9, 10, 10 ICSE, and you can like, subscribe or give your comment in the comment box and click on the bell icon to get the latest update. So let's start today's topic, magnetism. Here the topic of discussion you can see is the magnetism, the property of magnet. Property of magnet, here we will read what is a magnet. We'll able to know some properties of magnet and also uses of magnet. With that we'll get some important notes. So first thing to know here is what's magnetism. If we look here, the magnetism term is one, the magnetism. What is the magnetism actually mean? Magnetism is a property of magnet. Magnetism is the force given, the invisible force given by a magnet. When all the electrons spin in the same direction, means here we are discussing about the magnetic domain or the magnetic particles. When you bring two magnets together, they either will uh, push each other. Push means when two magnets are pushing each other, that is called force of repulsion. Whereas they are coming towards, means when they are pulling each other, that is called force of attraction. So that is the magnetic force. And as we know, magnetic force is non-contact force. So this force either can repel or can attract, because and non-contact force inversely proportional to distance square, means with the increase in distance the force between them will decrease, or with the decrease in distance force between them will increase. So this force only results the change of charges of electron in the magnet, or we can say the magnetic domain inside the magnet. So let to come the topic, what is magnet. So this one, if we look here, what is a magnet? Magnet is that type of substance which can attract to the substance having the same property. And this magnet first time we got from nature. For that, the name of that is the lodestone, which is having oxides of iron or iron oxide, Fe2O3, and ferric oxide. And this oxide we are having, or this ore we are having, ore were having some property that they were attracting to small piece of iron. First thing. Second thing, they are remaining in the a definite direction. When we'll suspend, when we'll take a thread and we'll suspend, that time they can remain in the specific direction, and they were not having a regular shape. So two type of magnet basically we can divide. First magnet is, which is what we are getting from nature, natural magnet. What we are making artificial, the artificial magnet. So what we can say is a magnet. Magnet is an object that has two poles. One is north pole, one is south pole. Here you can see in the diagram. Here one side is north and one side is south, and it is one side is having the blue color, one side red color, north and south. And this is a bar magnet which is looking like a English alphabet I, whereas English alphabet U, this is the horseshoe magnet or U-shaped magnet, where one side is north and one is south. So what I can say, the magnet that has two pole, north pole, south pole. So what more property of this magnet? Opposite pole will attract, mean north south will attract each other. This north and this south will attract, and this south and this north will attract. Whereas if we take two north together, two south together, both will repel. Means this magnet, which is what we are getting generally, artificially nowadays we are making this one. So that is called artificial magnet, which is having a regular shape, which is having the magnetic strength more. So we'll get two type of magnet. One which is found in nature as the natural magnet, having no shape, no regular shape, we can say, having the strength also very less, and the magnetic strength cannot change. We cannot increase or decrease this strength. But in case of artificial magnet, which are prepared artificially, which is having a regular shape, which is a magnetic strength more, so that is a artificial magnet. And this magnet having four properties. How we'll able to know a given substance is magnet or not? So for this, we are having some properties. It's called properties of a magnet. First property we'll look here, attractive property. Attractive property means a magnet can attract to a magnetic substance like iron, nickel, cobalt, and also it can attract to the opposite pole, and only repulsion possible when like pole come in contact, or when like pole face each other, that time only force of repulsion. For that reason, repulsion is the surest test for magnetism, because magnet can attract to a magnetic substance as well as opposite pole of magnet. Only it can repel to the like pole. So repulsion is the surest test for magnetism. Second one, if we look directive property. Directive property means if we take a bar magnet, which one the bar magnet? This use a magnet is the bar magnet. This use a magnet, that sorry, that I say magnet is the bar magnet. This magnet. If we take this bar magnet with a thread, it will suspend from a rigid support, then it will always remain in north-south direction. That is called directive property. Third property we will look here. No monopolarity. It means there is no magnet which is having single pole or one pole. All the magnets are having two pole. If we divide any given magnet into two pieces, we will get again two pole, north and south. One pole only north and only south. Not possible in case of a magnet. And fourth one, if we look here. Fourth one is the like pole repel and unlike pole attract. Mean north south, south not attract, north north, south south will repel. Here next one, if we look here, you can see in our magnet the induced magnetism. The term induction and conduction. Conduction means when they are in direct contact. Induction means when they are giving the force, giving the property, giving the energy from a distance. That is called induction. Induced magnetism. Induced magnetism means when the magnetic property is given to a substance from a distance. It is called induced magnetism. The process by which any substance, magnetic substance mainly, iron, nickel, cobalt, steel, all these magnetized by a magnetic field. Induced magnetism is possible when this magnetic substance will come near the magnet or come in the space where the magnetic force experience. So magnetic uh, induction or induced magnetism is temporary. Magnetic property which is acquired, which is gained by a magnetic substance when it is kept near a magnet. And if we look here, magnetic pole induced, if we look to this diagram here, this this part, if we look here, it is having a pin with a magnet. When any iron piece is coming near the magnet, to the nearer end, to this end, to the nearer end, magnet always give the opposite pole, because of which it will attract. And because no monopole exists, so we'll get the like pole at the far. So nearer end always will get the opposite pole, far end will get the same pole or like pole. This is the induced magnetism. And induced magnetism, if we look here again, induced magnetism case, we can give magnetic property to a magnetic material. So induction precedes attraction, means whenever iron piece is coming near a magnetic material, iron, when you are taking near a magnet this side having the south pole, and which pole will develop here? The north pole. And north south always attract, because of which we'll get the attraction. And this magnetic induction is temporary in nature, because up to how much time this magnet will remain near the magnetic substance. Means in this case, if we look up to how much time magnetic substance and magnet is near to each other, that much time magnetic uh, force or magnetic power will come near the magnetic substance. But once the magnet remove, magnetic power also remove. For that reason, induced magnetism always temporary in nature. If the magnet remove, the magnetic substance, magnetic material will also lose the magnetic power instantaneously. Means at the same time to lose the property of magnet. So for that reason, induced magnetism is temporary in nature. Look here, one more thing about this magnet is the magnetic field. Magnetic field means what? When we take a magnet, you might have seen one magnet will keep here, and iron when will bring near to it, it will get or will experience the force of attraction. When we will take another magnet near to it, if like pole and repulsion and unlike pole and attraction, this force will experience from a distance because of the creation of magnetic field in the middle. Magnetic field means the space around the magnet where magnetic force can be experienced, or the space around a magnet in which needle of a compass. What is a compass? Magnetic compass is used to know the pole of a magnet. This compass also used to know the direction when we are going in ship or aeroplane. Space around a magnet in which needle of a compass is in a direction other than geographic north and south. That means always magnetic compass remain in north-south direction, but once it will come in the magnetic field, they can go to any direction, because that time they will show the direction from north to south of bar magnet, or they will show the north and south of U-shaped magnet, horseshoe magnet. For that, a magnetic field is the space in which magnetic force can be experienced by a magnetic substance or a magnet. And if we look here, this all closed continuous shape are these all closed continuous circle which is showing the magnetic field of a magnet. So that line which shows the magnetic field of a magnet is called magnetic field line. Magnetic field line is a closed continuous curve that shows the magnetic field of a magnet. And here one more term if you look, here one term used if you look here. The definition if you look here, it is given one term is the tangent. What is a tangent? Tangent means whenever you will take a circle and a line passing outside the circle touch the circle in one point, that is called tangent. Tangent always make 90 degree with the radius. In one point only one tangent is possible. So a closed continuous curve in which uh, tangent at that any point will give the directional magnetic field of the at that point is the magnetic field line, or simply we can say magnetic field line is the line which shows the magnetic field of a magnet. So magnetic field is around which a magnetic force can be experienced. And we'll get now another one. If we look here is the another part of this magnetic field line. What are the properties of this magnetic field line? Means magnetic field line is closed continuous. That one first point. Means they'll start from one side and end in another side. Means they always start from north and close or continue to the south in a closed path. And tangent at any point gives the direction of magnetic field, what we got in the definition also. Third one, if you look, they never intersect each other. That means one line is going from north to south, another one also again will start from north to south, but in the middle will not get any point of intersection. Why will not get any point of intersection? If we'll get any point of intersection, that means in 1.2 direction, because tangent always giving the direction of magnetic field. If two magnetic line will intersect, that means in that point, in that same point, in this point, two direction will get two tangent in one point not possible, two direction of magnetic field in one point not possible. For that reason they never intersect each other. And if we look another one, they are crowded near the pole and far separated near the middle of the magnet. That means they start from north pole, means all the magnetic line are in the north pole, and they're continuing up to the south pole. That means all the magnetic line will concentrate in south pole. That means they are crowded near the pole. For that reason, pole. What is a magnetic pole? Magnetic pole is that place where magnetic force of attraction and repulsion is strongest. Magnetic pole is that place where magnetic force experience is more. In the middle, it is having less. In the middle, if you look, they are separated by a certain distance. They are not intersecting with each other, but near the pole, they are crowded, and outside they are moving from north to south, whereas inside the magnet, the line is from south to north. So here, one more parallel and equidistance. What we have discussed now, uniform magnetic field one means they are having equal distance in the middle, and outside the magnet they are directed from north to south, while inside they are from south to north, means reverse. So magnetic field line represents the magnetic field. Magnetic field, the space around which magnetic force can be experienced. Here, magnetic field of Earth. First of this video, if we look, I told that a magnet suspended with a thread remain in north-south direction. Why they will remain in north-south direction? That means there is certain force of attraction from the earth. That's what we are going to discuss. That what will prove, what is the evidence by which you can prove that earth also having the magnetic field. Means why, how can we say that earth is having magnetic field? First point, if we look that a freely suspended magnetic needle always rests in north-south direction. If earth is not a magnet, if earth is not having any force of magnetism, then why they will remain in north and south? Why not they will remain in east or west? So they are remaining in north and south is proof that earth also having some magnetic field, earth also having the magnetic force. Second one, neutral point are obtained by plotting magnetic field line of a magnet. What is next? Neutral point we'll discuss. That means when you are plotting the magnetic field, this one in practical also, practically also you can do by taking a bar magnet or magnetic compass in a paper. If we draw the magnetic line of a bar magnet, we will always get a neutral point. That proves that Earth is having the magnetic property. Third one, a iron piece it will keep north-south. Any iron piece you can take, it will keep north south and keep inside the soil for some time. Sometime not means that 1 hour 2 hour, it a long time you have to keep inside. That part will behave like a magnet. Means that magnet always, how a magnetic substance gain the magnetic property. First one by induction, what we have discussed, induced magnetism. Another one by conduction. Means it will take a magnetic substance, keep over a magnet. That is called single touch or double touch. Two method in that. So it will place magnetic substance behaving like a magnet. Magnetic substance obtaining or getting some magnetic force, magnetic energy, magnetic power. So here iron rod is becoming a magnet inside the soil. That means earth also having the magnetic property. Earth also having the magnetic power. So this proof that earth magnetic field. So earth magnetic field line when you take in a limited space. But I told that in a paper, we'll take a bar magnet, magnetic compass, and we'll draw the magnetic line. We'll get straight line. Here you can see a straight line. This one for this side one, if you look, it is for the compass. One side for compass and one side for the this side for compass, this one 1 2 3, and this one the magnetic field line. So we'll get in limited space always we'll get a straight line just which are parallel to each other. But when we'll take space more, that time we'll get a closed continuous path for earth magnetic field also. One more thing, term related to magnetic field. Magnetic field of earth, where magnetic needle become vertical is called magnetic pole. Like in a bar magnet we are having two pole. In case of earth also it is having two pole, earth north magnetic pole and earth south magnetic pole, and the magnetic field all around. Another one you will get here, magnetic equator. Magnetic equator and geographic equator are not same. Geographic pole and magnetic pole are not equal. So magnetic pole where magnetic needle become vertical, and magnetic equator, the line joining the place where magnetic needle become horizontal, means like this straight, is the magnetic equator. Whereas up to down you can see as the magnetic pole. Magnetic pole and geographical pole having little bit angle difference, and magnetic equator and geographic equator also having a some angle difference between them, means they are not same. If we look here, when we place a magnet uh, on a paper and we'll try to draw the magnetic field lines by using a magnetic compass, that time we'll get this neutral point. So what the neutral point is? Neutral point at which two magnetic fields are equal in magnitude, means the amount of magnetic strength is same but both in opposite direction. Means two magnet here, one is earth magnet, second is bar magnet, both are having magnetic field line. In a limited space, bar magnet having magnetic line closed continuous. In a limited space, earth is having magnetic line straight parallel lines. That means both are where they are having amount same, strength same, but in opposite direction. So resultant magnetism, magnetic force will be zero. In that time, compass can move in any direction. that is the neutral point. So neutral point case, net magnetic field resultant magnetic force is 0. Here you can see the neutral point. Compass needle rest in any direction. Here you can get two condition. First condition here, geographic north means here north pole of our magnet is facing to geographic north, and here north pole of our magnet is facing to the geographic south. Means we can keep the magnet north facing north or north facing south. So in both case we'll get a neutral point. Here you can get the cross mark which shows the neutral point. Means the direction of neutral point is changing. Look, when you are keeping north facing north, in one case south facing north. Both case we got the neutral point, that cross mark. But both one case is horizontal, then other case it is vertical. Means this neutral point we can get by using a bar magnet in a A4 size or a plain paper by using a magnetic compass. This is practically we can find out the neutral point of a uh, magnet or in a magnetic field where is the neutral point. This is all about magnetism and magnetic property. So go through this video. As I told earlier, what you have to do to get the new updates. So very soon I'll come with another topic, another video. So do the video, and any question you are having regarding this topic, you can give me your question or you can forward your question in the comment box. So if you will feel this video is helpful for you, like the video. Thank you very much.